So I wanted to give an overview of this polar graphs project. I know that this document is already online for you to take a look at, but I wanted to make sure that you would be aware of just um, how everything relates. Hopefully, maybe clarify a couple things here and there. So we'll just go ahead and read through this. So this polar graphs project, you will be doing both math and research about polar equations and their graphs. This project is going to be out of 50 points and will be counted as a quiz grade. From computer-generated graphs, you will use Desmos, so hopefully you have kind of gotten used to using Desmos at this point. Desmos will help you to create polar graphs that can be copied into your word process document. To access the website, go to desmos.com. You can link it to your Google account. You will most likely need to play with the settings, window, etc. as you create each graph. So essentially, if you want to, you don't have to link it to your account, but if you want to kind of save what you're doing so that you can close out the window and come back to it later, then you'll definitely want to link it to your Google account so that you can go back to those graphs and not have to enter them in again. So that's really all that is. If you just open desmos.com, you can absolutely just graph. You don't need to link it to an account. Okay, so there are two parts to this project. So part one is worth 30 points. In part one, there are going to be two sets of polar equations. We'll go over part one as well in more detail. But you'll have two sets of polar equations, each with an accompanying series of questions and observations to be made. You will use Desmos to create an individual graph for each equation, and then you'll insert it into a word process document. So your project, in the end, is going to be a PDF. It's going to have part one, it's going to have part two. I would suggest using a Google Doc, and as you're working on part one, come up with the individual graph and start putting them into the word process document. Make sure that you'll be able to label each graph, and the way you'll label the graph is you'll use MathType or some similar equation editor. In Google Docs, again, we'll go over a couple of these things as well, but within Google Docs, you will be able to use a math equation editor so that you can label the equation. For example, if it's in terms of theta, you'll be able to write in theta. Okay, so each set of equations is worth 15 points, which will be awarded for correctly creating all graphs, giving complete answers and observations, mathematical correctness, and mechanics. You'll have to see the grading rubric for more information on exactly how that breaks down. Part two is 20 points. This is the part of the project where you will get to research two polar curves. For each curve, you will provide at least two different graphs labeled with their equations using MathType. The two graphs should demonstrate the effects of transformations. So basically, you'll pick, so in part one, you'll basically find two types of graphs, two types of curves. Don't pick one of those for part two. Instead, for part two, you'll pick a different one, two different ones, and you will kind of do the same thing and kind of show off the different transformations by coming up with different graphs. Okay, now it doesn't have to be like a lot of graphs, it just says at least two. If you need more to demonstrate the different transformations, that's fine, but depending on your curve, there might not be as many transformations, so at least two. Write at least one paragraph about the polar curve, include the general equation, a description of how the transformations shown are manifested in the equation, and some history or facts about the graph. Give me information about its name, who discovered it, what it's used for, etc. There are many polar curves to be explored, and you are welcome to research any one that you find interesting. However, you may not use one of the curves we have discussed in class. So in class, we've already done equations of lines in polar form, equations of circles in polar form. Don't do any of the ones from part one, because that'll be redundant. So otherwise, any of the other curves that you find are fair game. All right, each of the polar curves you research is worth 10 points, which will be awarded for having all of the elements described above, mathematical correctness, proper citations, and mechanics, see grading rubric. Okay, now for your research, you may use textbooks, library resources, and the internet. You must properly cite sources within your project and submit a full bibliography with your project. Plagiarism will not be tolerated and will result in a grade of 0 for the entire project. So in general, the best rule of thumb is if you're not sure whether or not you need to cite something, cite it. Some good places to start off in terms of finding resources. You can use Wolf from MathWorld. It's actually a great site for anything mathematical. Wikipedia, you can definitely start there. Hopefully you all know that at the end of a Wikipedia page, they have citations, and you can use those to get to other websites that might have more information that you're looking for. So just make sure that, particularly, obviously if it's an analysis that you're coming up with yourself, that's fine. However, if it's any sort of information that you didn't know before, like just straight up facts, like who discovered it, if you didn't know that before, then you should absolutely cite it. At the end, just submit a full bibliography so that you have all the different sources that you used on one page as well. Okay, so if you create your own graphs, you do not need to cite those, but if you copy a graph from somewhere, then you should absolutely cite that, say where you got it from, cite it directly within the project, but otherwise, everything else you can just put into a bibliography at the end. We will spend multiple class periods working on this project. Use your time wisely. This is your opportunity to get help generating graphs on the computer, ask questions, choose curves to research, etc. Okay, your final project should be submitted as one printable typed document and should be submitted electronically. You may want to convert your project into a PDF file to ensure that all of your images and equations appear correctly, and I can definitely help you with that if you're having any trouble. All right, if your project has not been electronically submitted by the time you walk into class on this date, it is late. Late projects will be penalized 5 points each school day, whether our class meets or not. All right, and so the grading rubric is here on the back. So at the very top, we have potential deductions. Project is late, -5 points per day. Not typed in one printable document, -3 points. So make sure part 1 and part 2 are going to be in the same document. Just make sure that you have it as one thing. I don't want to have part 1 and part 2 and have to find in between the two. So each person should only have one PDF document. Lack of neatness, proper grammar or spelling, no bibliography, no citations or any improper citations. Part 1, you'll see set 1 and set 2, meaning you'll have one set of polar graphs, and for set 1, I will grade you 4 points for correct individual labeled graph, 1 for identifying the general shape of the graphs, and then 10 points for the observations and analysis on set 1. So that's 15 points. Same thing with set 2, that's 15 points, so part 1 has a total of 30 points. And then part 2, we have, this is the part where you're doing the research yourself. So these are 10 points for each different type of graph or curve that you research. So that's 2 points for the correct graphs labeled with equations. Remember, you have to have at least 2, so 2 points there. General equation, that's 1 point. Description of transformations, that's 4 points. And then history and facts, that's 3 points. Okay, so that's 20 points for part 2, 30 points for part 1, for a total of 50 points. Okay, so let's just go over part 1. So we have part 1, you can see set 1 and set 2. So on the left here, in set 1, you can see there are a list of equations. So what you're going to do is you're going to take those sets of equations and you're going to graph each one individually, label it with the equation. You'll use math type to label because you'll have to use theta in there. And then next to it, you'll see on the right it says discuss any general observations, and I list off different things that you should make sure to include when you are talking about your graphs. So same with set 2, you'll see the set of equations here on the left, and then on the right you'll have that list of things that I'll want you to make sure to touch on in your analysis of those curves. Okay. Also here there are a couple of things that will be helpful, so make sure as you are putting this into Desmos, use radians, show the graph on the interval between 0 and 2 pi. And now let's talk about how you're going to, well, a couple of tips including some on how to actually put this into your Google Doc. Okay, so a couple of tips. How to take a screenshot on the Chromebook. So to capture your entire screen, Control plus the Windows switch key. If you're only capturing part of the screen, that would be Control, Shift, and the Windows switch key. So hopefully that's a little bit helpful if you haven't done that before. How to access Equation Editor in Google Docs. If you go to the top of the menu, you click on Insert, and then under Equation, you click on that, and that will bring you up the Equation Editor. So when you insert a new equation, you can type in numbers, but you will need to put in any mathematical symbols by finding it on the menu. So for example, if you are inserting theta, you'll have to click on this menu here, and then this brings up actually all the Greek letters, which includes theta. All right, in terms of citations, you should have those included within the project itself. So if you take any picture, info, or facts that you directly use from a source, whether you quote it or if you even paraphrase it, you should absolutely be citing those. However, you do not need to cite any graphs that you yourself made or created using Desmos. You are absolutely free to use Citation Machine or any similar website to help you come up with those citations. So here's an example of a citation. If this is something that you didn't know beforehand or you couldn't figure out on your own and you found it out by doing research, then you should cite it this way with the parentheses, with the title and the year in at the end of that piece of information. All right, bibliography this is the part that is at the very end. This should list out all the materials and websites that you consulted as you worked on the project, whether or not you actually cited it in your work. So if you think that you read something that helped you understand it, even though you might not necessarily have written out that particular part that you understood, I would say just as you are doing research, just continue coming up with a list of websites or a list of materials that you are reading, and that way you won't have any trouble trying to go back and find that web page again. Your bibliography should be the last page of your project. You can use EasyBib or any similar website to help you come up with the bibliography. That's absolutely fine with me. Okay, so how to convert your Google Doc into a PDF. So on the top menu, click on File, and then click on Download As, and then you'll see an option that says PDF document, so that's what you'll want to click on to create the PDF. If it's helpful for you for the Part 1 analysis, you can use these questions to guide. So what is the name? What is the general equation? What gives the length of each loop? So if you kind of go through this and kind of make sure you answer each question, you should touch on that whole list of different things that I want you to talk about in terms of the different transformations on these polar curves. So hopefully that's enough to help get you started on the Polar Graphs project. Definitely let me know if you have any questions that I can answer, whether it's something about the polar graphs themselves or if it's something about logistics or formatting or anything like that. I would be happy to help.